Hello everyone. In today's video, we are going to discuss the implementation of the solution to the knapsack problem. If you are watching this particular video for the first time, I would suggest you to go back to my previous video wherein I have discussed how exactly the knapsack problem is solved using dynamic programming and how the various calculations are being done. Now coming to the implementation, let's start with the inclusion of the two common header files. I have included stdio and stdlib.h. Now in this particular program, we are supposed to write 3 or 4 different functions. The first is the main function, the second one is the calculation of all the values in the table by name knapsack, and one more function to find the maximum among two elements, because while filling the entries onto the table, you might have noticed that we need to call max function, as well as one more solution to print which are the objects that are needed to be included onto the knapsack. So sometimes it may so happen that we need to pass so many arguments to each of those functions. So to avoid all those things, we will write all the variables used in the program as global variables. If you are so concerned, you can take those variables as local and make sure that whenever you are calling the function, those variables are passed as an argument to those function. I am using it as a global right now. So first one is the number of objects denoted with n. Next is the knapsack capacity denoted with w. I will be using the same variables as I have used in the previous video. Next, weight, small w. I will assume that it is small. Next is profit denoted with small v, a single dimensional array, and capital V, a two-dimensional array. Now I will be taking this as my global variables, and one more variable by name x. I will tell you what is the importance of this x array later. So these are my global variables. First I will start with the max function. If a greater than b, return a, else return b. Yeah, this was about the max function. Let's go for the main function. As I have taken most of the variables as global, let me have a variable I to iterate my for loop that I am going to use in the main function. Now first, what is the first thing that we are supposed to do? We are supposed to read the number of objects. Print Now after number of objects, the second input was the knapsack capacity. Printf I have used the variable capital W to denote the knapsack capacity. Now, depending upon the number of objects, read the weights of each of those objects. Printf. Take a for loop for I is equal to 1. So this is the reason why I have declared the variable I within main. Ampersand of small w of I. Please don't get confused. This is capital W, which denotes the knapsack capacity. Small w denotes the weights of the object. Next. Read profits. read the profits of the objects. Same thing, run a for loop. Small v of I. If you do remember, I have declared two variables. One, a single dimensional array represented with denoted with a small v, and one more two-dimensional array to denote the table that we are constructing, which was capital V. So this was the input. That is, I have read the number of objects, I have read the knapsack capacity, I have read the weights of those objects, I have read the profits associated with those objects. Next thing, okay, the continuation of main function. I will call a function by name Knapsack, wherein I will do the entire calculation. Next, I will call print solution. Now, this particular print solution function, if you do remember, in the previous video, once I constructed the table, with the help of the table, I used the bottom-up approach to get the information about which are the objects that needs to be included onto the knapsack problem. This is about this print solution function. So I will just write a comment line. This will tell which objects are there in the knapsack. Now this is just a description. Now after this, I'll print this. Maybe I'll print the solution. Print here. I am just holding that information. Which are the objects that needs to be present in the knapsack? Once it is being done, I'll print for I is equal to 1, I less than or equal to n, I plus plus. So in the previous example, let me write a number of objects were 4 and the knapsack capacity was 5. The example that we considered were the weights of the object as 2, 1, 3, 2 and the profit, I think it was 8, 6, 16, 11. So these were my input. For this particular input, I constructed the table and with the help of the table construction is there in this knapsack function. And we print the solution means, okay, we were able to get which were the objects that were included onto the knapsack. After that, what we will do is, I know the solution to this is third object and fourth object needs to be included. What we will do is we will keep an array by name x. We will keep an array by name x. If you do remember, I have declared a global variable by name x. Now this x will have 0, 0 after solving 0, 0, 1, 1. Now what this 1 and 1 implies? It implies that the third and the fourth objects needs to be included. This 0 denotes that the object first and the object second are not included onto the knapsack. So what I will do to print the final answer, I need to go through this entire array, that is this array x, and I should tell which are the objects, that is object number, weight and profit. Object number is 3. Weight is, what is the weight? Third object weight is 3, profit is 16. Next, object number 4, weight is 2 and the profit is this one. The maximum profit is 27. So for this, I'll just print this first and then I'll print the max profit. The max profit is 27. First I will print this. So to print this, I need to run a for loop from I is equal to 1 to n. If x of I is equal to 1. Now initially it was declared as a global variable. As it was declared as global variable, initially all the location of x will be zeros. Now I will do some updation in this print solution to update this to 1. Don't worry about it right now. Assume that after calling this print solution, I am going to check if x of I is equal to 1. I need to print. So printf. What is that first one? First is the object number, that is an percentage D, a tab space. Next, percentage D, a tab space, percentage D, a new line character. What are those? First is object number, that is I comma W of I, small w of I, and then small v of I. Return 0. Now, before closing, we'll print the max profit. Max profit is percentage D. What is this max profit? This max profit is nothing but capital V of N and W, capital W. Return 0 and close the main function. Now, if you want to print this label, object number, weight, and profit, before this for loop, have one more printf. First is object, a tab space. Next is weight, a tab space. Then profit, a new line character. So this was about the main function. Now quickly we will write the knapsack function as well as the print solution function. They are very small functions. Void knapsack, no arguments, int ij. Now if you have noticed that the first row and first column were 0. So what I will do, for I is equal to 1, I less than or equal to n, I plus plus. This is also a for loop. For j is equal to 1, j less than or equal to n, j plus plus. Hope we are doing a mistake. What was the mistake? We had a 0th row and 0th column also. So this for loop, the outer for loop should be from 0 and even this inner for loop should also be from 0. What is the first thing? If I is equal to 0 or j is equal to 0, either first row or first column, capital V of I j is equal to 0. Else if, what are the other two cases? J minus wi. If, how to write this? J minus wi less than 0. If j is less than wi. How to calculate this? V of I comma V of ij is equal to V of I minus 1 comma j. V of I minus 1 and j. Please don't use comma. It's a two-dimensional array. Else, how to write V of ij? V of ij is equal to, do remember this formula, max of V of I minus 1 and j, comma, V of I minus 1 and j minus wi. It is V of I minus 1 within the bracket and then j minus wi also in bracket, but w is also an array. This is small w. Note that this is small w. Small w of I plus small v of I. Maximum among these two. The calculation is done. Then you close this. If you want to print this table also, you can print it. You can print this table. What you can do, you can put a printf here itself. Printf percentage d, a tab space, v of ij, capital V of ij. Now close this first for loop. Now if you want to print it in a tabular form, have a new line after first row. Close the second for loop here, this for loop, and then this function. This was about a knapsack function. Knapsack function was quite easy. First row, first column 0. If j less than wi, this value. If not, this particular value. Now we'll go for the print solution function. Void print solution. I'll take variables I and j. If you do remember, we came from the last value v of 4 comma 5 compared with v of 3 comma 5. It needs to be iterated. So I will take this. I have taken this I. Initially I value as n and j value as capital W. Capital W. Now I take a while loop. While j not equal to 0. If you do remember, when I was using a bottom-up approach, I need to stop at whenever the knapsack capacity, the remaining knapsack capacity was 0. While j not equal to 0, we'll use okay. I will iterate even with I also. Don't worry. While I not equal to 0 and j not equal to 0. Now how we calculated the value? If v of ij not equal to v of I minus 1 and j. If this condition was true, then it implies that I need to consider that particular object. So I am x of I is equal to 1. This is where I am using this x, which implies that I am considering that particular object onto the knapsack. And then I used to reduce the value of j. J is equal to j minus w of I. This is once again, w means a small w of I. Close this and then decrement the value of I minus. Close this while loop, close the print solution function. This should be fine. This was about the print solution function and the entire implementation of the knapsack problem using the dynamic programming. Hope it was clear. Thank you.